Hello, and now we're going to look at how we can identify different functional groups from their IR spectrum, the infrared spectrum. Okay, so different bonds like we were talking before vibrate and absorb different infrared frequencies, and that's shown as the wave number. So here we got this carbon to oxygen bond, and that can be found in lots of different functional groups. You've got it in alcohols, carboxylic acids, esters. We've got the C double bond O, that can be found here as an example in an aldehyde, a ketone, a carboxylic acid and an ester. And they've got different numbers, okay, different ranges. So there's not one fixed value where it is. Remember, these peaks aren't straight lines, they have a certain width to them, so that's represented within the range. We've got the carbon to hydrogen, okay. Now, all organic compounds pretty much have a carbon to hydrogen bond. So that one's not massively useful for identifying different organic compounds because they've all got that bond. Okay. These two are quite interesting ones down here. We've got the one here for a carboxylic acid, oxygen to hydrogen in a carboxylic acid. That is very broad, as we'll see in a minute. It's a very broad peak. And if you look, it actually overlaps, its range, it overlaps with the carbon to hydrogen range. Okay, so quite often these peaks overlap with each other. We'll see some examples in a minute. And then the other one, the other OH is the OH of an alcohol. So the OH of a carboxylic acid and the OH of an alcohol, the bond there and the bond there, vibrate and absorb different frequencies. And one is very broad and one is broad. And it's important that you understand this difference between very broad and broad because their ranges are very similar. So this helps us identify an alcohol compared to a carboxylic acid. You're not expected to remember all these ranges at all. They're always given to you on the back of your periodic table in the exam, on your data sheet. So you just got to understand how to use them. Right, let's look at an example. So the first one we're looking at here is alcohols. Okay, now alcohols then have a spectrum that looks something like this. This is a methanol here as an example of alcohol. And if you start off this side, we very rarely really look much below 1,500. Okay, what's down here isn't much use to us really. It's what's called the fingerprint region. Now, a computer can analyse that and tell you pretty much exactly what molecule you're looking at. But for us, it's all a bit random. We don't look at it. We don't bother with that end. We look more this side. Okay, so on the left-hand side of the graph, it's always useful. This here is the alcohol peak, okay, the OH peak, I should say, the OH bond. So when this bond here vibrates, okay, it shows this absorption here. So that's what I mean by broad. It's not very sharp. Okay, it's a broad peak. Here you can see it's slightly overlapping with the CH peak. So this peak will always pretty much be there in all your spectrums. Sometimes it's a bit longer, sometimes a bit shorter. And that depends on what it's being compared to, really. What the other peaks look like. This over here, don't bother with. Here, CH peak. This one, the OH peak. 3,230 to 3,500. Okay, always about there. So that tells us it's an alcohol. So alcohols are one of the ones you've got to identify. So if you're looking for an alcohol, you're looking for a peak here that's broad. Okay. Let's compare that to aldehydes and ketones. And we do these two together because you can't tell the difference between an aldehyde and a ketone just by looking at the infrared spectrum, because they have the same type of bonds. Carbon to carbon bonds, carbon to double bond to oxygen, carbon to hydrogen. Okay? So now there's something over here. This would be the CH bond again. Okay? So that's always there around the sort of 3,000 area. It's always kind of spiky, so you can kind of recognise it. I'm not going to bother to label it because everything's got a carbon to hydrogen bond. It's not important really. This big whopper here is what's important. This is the carbon double bond to oxygen. So when that carbon double bond oxygen vibrates, you get a big peak here, 1,680 to 1,750. Okay, that there tells us that we've got a carbon to double bond oxygen. But if we look, what's also interesting is not always what peaks there, it's what's not there. There's no OH peak, so we know it's not an alcohol. Okay, So this must be either an aldehyde, like here, ethanal, or a ketone here, like propanone. Okay? Right, the third one you need to know about are carboxylic acids. So, carboxylic acids. They've got something similar, okay, to aldehydes and ketones. That's that double bond O, and there it is again in the same area. Carbon to double bond to oxygen. There we go. Adsorption peak there. Now here though, we can tell that it's a carboxylic acid rather than a ketone with an alcohol group, because the OH group is in a slightly different place to where it was when it's an alcohol. Okay, if we look back at the alcohol one, okay, compare the two. So the top one's alcohol. You see this one's not as broad. It's a skinnier peak. This one is wider. It's actually so wide it's swallowed up a lot of the carbon to hydrogen bond. You kind of got that kind of like a lump growing out the side of it, because it's so wide it's swallowed up that bit there. Okay, so it's very broad. It says that on your data sheet that it's very broad, and this one here is broad. Okay, it's also in slightly different places. So the one for an alcohol is slightly further to the left compared to the one for carboxylic acid. If you look at this one, it's sort of hovering over 3,000, while this one's getting closer to 3,500. Okay, so that's how you can tell the difference between the two. So a carboxylic acid would have the OH, which is very broad, slightly lower down, and the carbon to double bond oxygen. Okay, here, those two peaks. While the alcohol doesn't have a peak here. There's no carbon double bonded to an oxygen, but we do have the OH there, but it's further up, or further to the left I should say, and it's not as broad as it is in a carboxylic acid. So those three spectrum, alcohols, carboxylic acids and aldehyde stroke ketones, are the ones that you need to be able to analyse and understand.